We went back to an older version. So here today, Coffee Compiler Club. Here today, talk about coffee and compilers and whether or not I'm on which end of Zoom's A/B testing on their UI. The act of changing it daily on me has like really driven me nuts. I hate it. Fucking pick one, dude. All right. Um, yeah, we're all being recorded live. We'll show up on YouTube in a couple hours. I don't care. I don't have any set agenda. So if somebody has something they want to start with, we can go. That's my spiel. If we start, we can go. Otherwise, I'm going to pull something out of my hat.
I got one thing.
Yeah.
So I've been thinking about this pretty much since I started the compiler project, and all compilation is a form, or at least one form of interpretation. What do you think about
Yeah.
that assertion?
Partial evaluation. Yes.
Okay, all right.
These
I'm
are
good
all
with
very
that.
similar.
Yeah, I've been looking into abstract interpretation lately,
Yeah.
and I think it's kind of a cool concept that seems very French and European, and doesn't seem like it's made its way into a lot of compilers just as a default.
No, no, it has made its way into a lot of compilers. It's not necessarily called that directly, but there are
Yeah,
plenty of folks who say I'm using abstract interpretation to partially evaluate this interpreter to build a compiler from an interpreter kind of thing or whatever. There's a lot of that kind of stuff floats around.
yeah. I came across a cool paper. It was Matthew Lemaire, and his title is "SSA Translation is an Abstract Interpretation."
Yeah, I
And
thought Matt threw. Go ahead.
you know that one?
I thought Matt threw it out on the coffee club reading list, but a couple sessions ago. I remember
Oh,
seeing it come around not long ago.
yeah, you're cited there in the first paragraph.
Well, there you go. Well, how old is this paper then?
It's 2023, January
Oh,
2023.
all right, fine.
I'll drop it in the
Yeah,
link
yeah, all good.
thing. So that's all I've been thinking about.
I would argue any typing is abstract interpretation.
Any typing
Yeah,
or compilation?
Typing.
typing too is definitely interpretation.
Yeah,
Forward flow typing. I've got this thing's at this type and this thing's this type. Okay, what's the intersection of the domains? What's the union of the domains?
yeah, right.
You can solve a lot of problems with like a stack machine kind of interpretation of both the type side and the value side. That's what I'm kind of leaning towards, is that
What's the difference between
what
values and types?
yeah, that's true. Yeah, I mean it's a type is what a value is, right?
I usually think of it as a type is a collection of values. This is the set interpretation of
Okay,
types.
yeah.
There's also the operational interpretation of types, which I know Cameron leans toward, and I kind of blend them as I go.
Well,
So
they have to be at some level, they have to be the same thing. We know that. So it's a question of which concept makes it easier for you to work with it.
yeah, yeah, there it is.
Let those sets contain sets themselves, you start having fun. And when you let them contain sets and
But
inversions of sets, now you start getting
what's
close
an
to
inversion of a set? Complement? No, something else. It's certainly the case that I view types as recursive collections. It's also certainly the case that I get types into, therefore, graphs with sharing and cycles. And then, it was the AA big explore on what the hell can I do with cyclic types is one of the big explores there. What can I do with cyclic types? Um, One of the things I can do is I can say, since it's a graph, I can throw graph theory at manipulations, and suddenly a lot of the manipulations on types become sort of trivially easy. Not trivial, but easy.
It seems the only domain this abstract interpretation, aside from like there's some static analysis, but one of the stronger domains is used in is like avionics and automotive static analysis. There's two. I think there's one called there's a compiler or a static analyzer. I think it's both. I haven't really gone into deep. It's called Astree, Astree. It was developed, I think, with work with Cousteau, and it was used in the. There's almost guaranteed one of you have flown on a plane that was checked by verified by the by the compiler,
Right.
and they're doing it to. The finding is that a model checking isn't the full you won't be able to check a system with model checking. It'll a bounded model checking. You'll stop somewhere. Whereas with this abstract interpretation, you'll be able to trace through a program, through all of its states, through all of its time, and be able to find errors that you wouldn't be able to find. Essentially finding there's basics would be interval analysis, right? We're saying the range of something is 0 to 10, and we're not going to exceed this range, or we're not going to go below this range. And you can say that's like a constraint. But then there's when you combine multiple states, then the constraints start turning geometric, and this time and state starts turning into a whole bunch of waves that if you wanted to fit that into an analysis or even a unit test, it becomes hard without actually like interpreting, without this kind of abstract interpretation, essentially. So that's kind of what I've been thinking about.
Okay. Cousteau's done a lot of groundbreaking work. Should be interesting.
Yeah.
So I wanted to, I had some papers in my presentation. So there was this one paper, tracing versus partial evaluation, comparing meta compilation approaches for self-optimizing interpreters.
Yeah, throw the link
so,
in. You can't just quote it out loud.
Fine, I'll put the link in. Okay. Yeah. So there, the link is in the doc. Now, so basically what this says is they said, you can approach optimizing in one of two ways. You can take this sort of static view where you have a program and you're partially evaluating it and you're specializing it to whatever. Or you can take this very sort of dynamic view where you're just tracing the program execution, and when you trace it, you record it, and then you're like optimizing the program execution based on the traces.
But isn't that what every tracing compiler on the planet ever does?
Right. And so what they basically said is that, we compared these theoretically and they're about the same, and we compared them in practice and they're about the same. But tracing is like so much easier to think about that you should just always use tracing. So,
Yeah.
yeah.
It's one of these deals where like there's a place in the compilation spectrum for tracing, and C2 always in the end at more expense for generating code generates faster running code. I pulled the paper up and was looking at it. I should have put it focused in. It's a strategy.
I mean,
There are other
PyPy
strategies
basically hit a wall
not
at
claiming one
about.
dominates.
Yeah,
PyPy
and then
is doing
there's
a tracing JIT and hit a wall at about half the performance of JVM.
Who was doing
then
that?
there was
PyPy, Python interpreter
PyPy.
written in Python.
yeah. So then there was this
It's very much a
second
tracing JIT. It watches what the thing's been doing the first 3 times you call the function, and then if it followed the same paths, it builds special.
It does tracing, yeah.
Here's the
Yeah.
assembly for that.
So then there was this second paper, which is like, oh, well, okay, if partial evaluation is bad and tracing is good, then how do you do tracing properly? Because that was the other thing I was reading about, is there was this like endless turf war between like method-based JITs and tracing-based JITs. And
Yes.
the tracing JIT people were like, oh, well, it's really fast. And then the method JIT people were like, oh, but like it gives better performance, baseline to use the method JIT. And so then there was this other paper, let's see, promulgating different JIT compilations in a meta tracing JIT compiler framework. And I
Yes.
guess it comes out of Japan because I don't know, Japan knows how to make fast things.
Part of the problem,
Large.
part of the problem is that the same implementer doesn't generally implement two of these.
Yeah.
So you take Cliff, for example, he built things a certain way, but he never tried building it the other way because he looks at it and he's like, why would I ever do that? But
Exactly.
to get compare and contrast, you'd really want Cliff to go back and build a tracing JIT, right?
Right. Yes.
And
So
but
the
what?
Google
Cliff might
Node
even
team
enjoy it
tried having the same
once he got
people
past the
write.
emotional side.
No. But see, what you don't know or won't remember is that I did this. Much younger Cliff did these things, and the answer was you could only go so far. It was pretty clear where you couldn't make any more progress. So I didn't bother doing it again. I between the ages of 15 and 18, I did a bunch of compilers, not just one. I talked about, hey, I did this Pascal compiler. No, I did an optimizing fourth. And then I did a tracing JIT, essentially a tracing JIT version of an optimized fourth. And it was pretty clear you couldn't do optimizations across the borders. And you needed that to get to the next level. So I started going to grad school. It's like, oh, you need these larger method chunks. So you know something what the fuck's going on around the hot loop, not just the short lead-in path to it and the loop itself. You needed all the other stuff. Never mind. Yes.
I had a professor who used to say everyone should write a fourth interpreter by both definitions of fourth.
Yeah. By both definitions of fourth. Oh, that's a lot of interpreters, though, if you're doing that
Yeah,
count.
he was like, the first time you write an interpreter, you don't know what you're doing. The second time, you think you do. The third time, you're starting to generalize, and your fourth one's actually good.
Okay, fair enough. The hotspot interpreter probably was close to my fourth interpreter, and I didn't write it. I routinely updated and improved and twiddled and tweaked, but it was an interesting approach to interpreters I hadn't seen
You
before.
inherited what? The anamorphic,
Yeah, Anamorphics, yeah, interpreter. It was, I'll say Robert Riesmer, maybe mostly did that interpreter.
which was a small talk interpreter
Originally,
at
yeah, it was
first.
self. Small talk became self. Um, David Unger started a company to go do these, dynamic execution, blah, blah, blah things using self. And that was picked up, called Anamorphic, got picked up. And then a couple of his people joined Sun, and I came in a little bit later. And they had that interpreter going, and they had morphed it to Java bytecodes. But at that point, the refinements were shit like it's going to be an assembly, it's going to be a bunch of assembly pieces. You need to have dispatch. Dispatch is the most expensive thing in an interpreter. So you need to break the dispatch up into the different parts because there's a delay between when you can grab the next bytecode execute and when you can jump to it to start going. And you need to have that delay covered by the other things the bytecode's supposed to be doing. And then there was some bunch of one-off stuff in Java. The bytecodes did a first time init, so we could swap the bytecode numbers using spare bytecodes out of the 256 bytes to represent that we've already done the one-off init. In particular, field offsets would be known after a class was loaded and had its layout made and things were done linked and whatever. And so all your field load guys, if they were uninitialized, said, I am this field in this class. And if they were initialized, they said, the next 2 bytes are actually the offset to the field and not some random class indicator, field indicator. And so you did a lot of refinements there. Oh, and there was a clone of the interpreter 5 ways. You had a top of stack was cached in a register and was known to be an int or a float or a pointer or a long or a double or was void, was not cached. And then you could run the bytecodes together and I guess we didn't run them together. It was not a tracing jet, but you would not have to reload or unload or whatever. You got to it again, a push pop add. You knew something about the stack and could do things. So that was a pretty refined interpreter, and that was one up from what I had done, the last interpreter I had done. So maybe, but you should do a fourth for sure. And I guess for interpreters will give you a lot of practice doing interpreters. All right. Good advice from
Do you have a
Stanford
sense
Prof. What
of
else?
how hard a fourth interpreter is? Would you assign it to a group of undergraduates
Yeah,
for 2 weeks?
yeah, yeah. And that's about the right time. I mean, by the time, I guess my first one took maybe that. By the time I had done it a few times, I could slam one out in a day. And I did so for a class at Texas A&M, and the prof looked at what I did and said, "Fuck, get out of here."
Because like simple took a lot longer than that.
Oh yeah, oh yeah. No, no. Fourth interpreters are, and you have to write assembly code if you're into writing assembly code. But then they're like nothing to it. Yeah, that's what I'm saying. I'm with your dude. Everyone should write one just to discover just how easy they are and just how meta they are. It's a great lead into what you can do in a compiler. All right. If nothing else, I'll pull out a lecture because somebody on the interwebs asked me to talk about range check elimination, and we had the discussion on Discord about control edges everywhere. One of them was range checks.
Yeah, we do need to get better at clipping out these lectures and putting them as separate videos on the channel that have like names.
Yeah, yes, I got an issue open on Simple. Find all these videos. And Derek pulled a bunch of them out. And I think I even put a link in the Simple, but I should break them up by their chapter appropriateness. That would be a big pile of work there.
Okay, let's eliminate some range checks.
Yeah, do this without slides here first go because I don't want to get formal on it.
Just for fun, you can use the word abstract interpretation while you're going.
Yes, we're going to abstractly interpret how to do things. So the V8 guys put control edges down everywhere because they had side effects they were trying to deal with. And my C2 learning was to expose all those controls as control flow, and then let the optimizer go to town on the normal control flow. And with a little bit of teaching on how to deal with certain kinds of common patterns that Java at least had, boy, you could get rid of a huge count of the control possibilities floating around. And I assume the same would go with JavaScript. And I know Apo was on a little bit, and he threw out this link to ECMAScript plus plus and said, "See, this sucks." I said, "Sure, it has more checks in the Java version, but not like an unreasonably count more." So I claim the same strategy seems to be what it might do. So this is all, what do you do with these things? Well, in the going back to your abstract interpretation, um, there are two big ways to clean up all this control flow. One is via the types, and one is I actually have to restructure the program. The type flow one covers everything that's true at a single point, and in particular picks up all those things that we would call values. Nate was just saying, "Hey, are we doing something with values?" Yes. So if the value of a pointer is known to be not null, you can throw the null check away. And that's an if test saying if null, and then often he goes to the weeds or not. And how do you represent that? So in the IR, like I do with C2 and with simple and AA, when I come to a test that wants to guard on a value, I throw a cast node in. The cast does take a control edge to an if test, which guards, and it does a cast. Now, what's a cast? Cast means that in a lattice, I'm going to do a join. I'm going to lift you from whatever type you were before to this plus whatever I just discovered from an if test, which is usually not null. So it strips the null possibilities off. Now I have a value that's known to be not null, and I feed it into a load or a store or whatever. So loads and stores don't have control edges, and they float around pinned behind a cast which removed the null possibilities. And then the optimization on the casts mostly says, if my input is known to be not null and I'm casting away nullness, I'm a useless cast. I should throw myself away. And as soon as he optimizes away, the thing that fed from him, loads and stores looking for a not null, lifted their input to a higher place that proved not null. And pretty soon, very top of the program, someone proved not null on your pointer, and the rest of the program is all like free floating loads and stores, and you're all good. So that strategy of using a cast as the pinning point behind a test is what I do for things that have a single value property. Range checks don't have that property, not so easily. They say I is less than n. So there's two things going on. There's some I and there's some n, some length. And so for those guys, I actually put the control edge on the load or store that then pins it behind an if. And the problem is that the points where you can lift that by removing the if are much fewer and far between unless you, well, without getting to the point where you do something tricky and the new if that you're guarding behind over the old one doesn't look like a range check. And then the load gets confused. Am I pinned behind a range check? I should be pinned behind a cast or an obvious range check. And you start to get into the point where it's difficult to do more optimizations after that. So that I tried a couple of versions of that. I want to call it the Oracle model, where I just knew something was true and I would just like, hey, I'll just know this is true and move the control edge up higher. And this allows some other optimization, but no more after that. And then because it was confused, as soon as I inlined this function into something else and something else, and I got a great big old program that had 27 of these things floating around, I couldn't common them up because they had different control flow edges. And it wasn't clear to me that it was legal to say that this load here and this load here, which have the same index and same pointer, but different controls, are the same. Or if they were the same, which control should I use? So I backed off from that. And I went into the range check elimination as an official pass. And under the range check elimination pass, you don't get to the loads input. I basically made the loads pointer input come from the prior loop, or prior code, which did the check. And the load goes around to not having a control edge and can comment up with other loads with no control edge. But they all share the same pointer, and the pointer was known to be range check, but it was an official, I did a pass, the pass found the loop had a range check, so I put a range check above here that covered the body of the loop, and I put some cast that said, you're now range checked, and then the loads all took from the cast. And the cast was not a value meet join cast, it was you're range checked. And it didn't carry the information in itself to show that I was less than n, because the loads ought to have shit like I plus 1 plus 2 minus 1 because you talk to array elements pre and post. You do. I'm doing bubble sort. I need plus 1 and minus 1 on the things I'm talking about. All the offsets are different, right? The range check guy figured all the offsets out, did the right math above, but the cast node couldn't pick out those pieces and say, this says that the value I produce as an index is between 0 and n, except that plus 1 and minus 1, so it's between -1 and n minus 1, or whatever the right numbers were. It couldn't do that. So it was just an opaque, you can't do anything here and give it up. But it's correct at that point, and no further optimization is going to happen across that border. So that was sort of the general strategy for range checks. Then once the loop body got cleaned out of range checks, it was tiny usually, and then you would unroll the loop and performance flew out of that. And you had some pre-section of code which did some stupid min-max math over all the array offsets that it found in the body of the loop. And if you failed, it jumped off to the interpreter and said, finish the job and throw an exception in the interpreter. That was them's were the strategies for range checks. How does that apply to people's JavaScripty notions? I don't know. Things I looked at, APO's list of things that went on ++. He asked questions like call get value and toNumber, and then when you're doing the math, put number, and there's a is big integer in there. And it was either you were a normal int or a big integer was your only options. You didn't get another option. A lot of those look like value calls, which go to the easy route of just had a cast that will join you up. Are you a subtype that contains an overridden get value and overridden toNumber? That is a value call. That is, I am a subclass of something, and the subclass contains an override or it does not. So that's a value call, and that's the easy good one. So I claim a lot of the things that I just looked at half an hour ago would fall the easy way. I'm back around to telling VA guys, don't put control edges in everywhere. Just expose the stupid tests. All right, done. Everyone's mind off somewhere else. Fastest coffee compiler club ever. What
I was
else?
listening.
I have a problem that I've hit before that I can talk about with simple, and it hit AA a bunch, which I sorted in AA, and I was trying to not sort it the way I did. It's such an easy thing. This is actually code. We should do this. This is code. This is
I'm
stupid.
curious how you think about the problems in AA different than simple that lead to reaching for different solutions.
Oh, I was trying to not do some super heavy theory weight things that in AA I was totally reaching for, and they solved the problems. Um, and then in simple, I say, I don't need to do that yet. And then I hit the point where maybe I do need to do it. And I don't know if I have to do the bad theory thing here. Or if I'm just, being obtuse for no good reason. Um, I want to do this one. Um, I want the scanner one. So I'm busy writing simple code here. I'm heading for methods. So, and I'm heading for, I want a string. We got to figure out how to get the damn code blocks start. See if I can get color coding on here. There's some hack you do. Format. Yeah, there's some colors, but it's pretty lame. Oh, all the indents are fucked up. Well, there you go. Yeah. What the heck did I bother? Wow, he put 6 space indents? Mr. Cut and Paste, excuse me. Um, yeah, this is weird. Okay, so let me fix a little bit of indent. Somebody else can fix it to 4 space instead of 6 here and 4 there. I don't understand where that came from. So starting life, I'm making an object that's going to be essentially class-like and have method calls on it. And I'm trying to sort of incrementally squeeze it into the existing syntax, which I planned for it, so it's not a bad squeeze. So I have some struct here. I'm going to claim it's a scanner. It has an index into a buffer. Well, I didn't do that at all. Thank you. It has a buffer of read-only characters. You're going to read the buffer and you're going to scan. You're looking for white space and you're going to parse out numbers and that kind of thing. So here's a skip white space call, and it just does kind of the obvious thing, except it takes a scanner, so I'm not up to methods yet. So I have a function that's embedded as a field in the scanner object. It's a final writable field, that's skip, final field. It has a function body. The function is take a scanner, that'll be your this pointer at some point. Grab a character. If it's less than or equal to space, we're going to declare white space and we're going to bump the index. Skip white space, pretty easy. Here's peek, which is just skip white space and then return true or false if you found the character you're looking for, and it lets you parse. Eventually, I'm heading for. I'm going to parse a set of numbers and do some bubble sort and common code problems in many languages. Bubble sort, which reads a list of numbers and sorts them and writes a list of numbers. Most of the code is in reading and writing numbers. Fine. So I'm trying to write this stuff. And I'm looking at the definitions here. Is this like pretty obvious what I'm defining code for here? Is this like easy enough to understand?
Yeah, it seems right. Yeah.
You see what's going on? Okay, so when I'm parsing, the parser comes along and says struct scan. Okay, I'm defining a scan object. And I don't know what's in it yet. So I parse a while and I get an X field. So I put my X in it. And I parse buff and I parse skip. And a skip field's coming, but I don't know what skip is yet. So I go ahead and do a standard parse of this. Well, this gets me a function pointer who then has an argument scan. Well, I don't have a scan object declared yet. So I get a forward reference here.
Yeah.
Okay. So then I'm done filling this out, and skip is defined to be a field in a scan object that contains a constant value, which is a function pointer. The function pointer internally carries a scan object as a forward reference. Repeat, same thing for peak. Okay. Now I close my definition off on scan. What is the definition for scan? Well, I have these types, and I'm going to use a ASCII representation of the types. So when I talk about scan, I make a pointer. Okay, I have a pointer to a scan thing. And the scan thing is just what we're looking at here, and it's known to be a struct, and the struct has some fields. Okay, the other things I can say about structs, or I'm going to get into, is whether they're read-writable or final, and some other things that show up in the ASCII print version of scan. But I'm just going to write the type out here. And so in the type field here, I'll have a field X. Whose type is an int. It's mutable, so there's a bang involved somewhere that says not final. So I'll just say not final, it's mutable. It has some other things, but that's the big ones. There's a buff. It has an array of U8, which is recursively struct. I won't go into that. It's an array. It is final deep. So buff is final, and the contents of buff are final, and those are separate things. So I guess I could put my twiddle here. Okay, that's fine. I have a skip. It's a field. It's typed to be a function. The function is now typed to have a scan object. Okay, it's pointing to a scan. And what is the scan here? Well, at the time I made the function, it didn't have a scan. So the structure that got made is an fref. So I actually have an fref here for this scan object. Now, what's the right syntax here? It's not a full-fledged scan object yet. And that's an argument list, and the output is it's a void return, effectively. Let's call it 0 here. And then there's a peak. And he's got a, scan fref, and he also takes a U8 as the character, and he's returning a bool. So that's my current type when I get out of that piece of the parser. And as an fref, life is like obnoxious when I start peeking through things. So I come down here and I say scan.peak. It's really I'm trying to say s.peak here eventually. So what is S? S is a scan object. What's a scan object? Is this. So I go to a peak. What does peak take? He takes an fref. He doesn't take a scan. Doesn't take a scan, takes an fref. So I want to close the cycle here. I want to get rid of these frefs in the type system. So I'm going to go roll through and find them. Now I have these other weird problems going on. One is types are immutable in the type system, not field immutable or not read-write immutable, the type object itself. So what are these things? They're little objects, Java objects. And like a scan thing is a type struct. It has a name field called scan. It has an array of fields. It's 4 long. There's 4 fields. It has a couple other flags. Those are all immutable. And then I intern them because as a natural process of doing everything with compilers and parsers, you typically start with some types, make small mutations to them, and get a new type, which will almost always be a type you have seen before. And so the hit rate on the interning in the hash table is some ludicrously high numbers, like 99%, 99.9% hit rate. It's huge. C2, a mid-sized compile will make some thousands of types and no more, even if you have 10,000 nodes and they make references to 10,000 type-like things, you only have a few thousands of types. You go to 100,000, it's topped out. You don't get more than a few thousands of types. And they're tiny and they fit in your L1 cache, so it's really nice to have this interning property going on. It also means an equality check on types is exactly equal, pointer equals, because you're interned. And then meet is generally done as a recursive descent, except I do field by field meets. And then the shortcut on meet is if you have the same field, you're equal, and you get out, no change. So all of these things turn into, it's pretty damn fast to make types and meet on types and ask the is a question, which you ask a bunch about, is it correct or not? And then performance optimizations all say constant propagation. It's all like, hey, you're an int, you're a 3, 3 is an int, you're a 4, I meet 3 and 4, you have a range 3 to 4, whatever. They all fall out of the type lattice thing. So, but here I am stuck with this kind of a game. And if I do a few go rounds of calling myself recursively, I'll get these deep scan things where they bottom out at a forward graph. And because there's a cycle here, no amount of recursive descent walking the types will ever close the cycle. You have to either always stop and go back to a global source like the types that the parser maintains, a mapping of types. And then when you say, I found a reference to a named type, I just look up my table. And that closes the cycle. That changes this fref here to a lookup in a global hash table. And when I do performance work, optimization, and the code I'm writing right here, I know my buff happens to be an array of 3 characters. They're blank, blank Q. Can I optimize this and say, oh, the result of the peak is true and the index has been bumped forward? Sure, I'll just do a little constant propagation. What's constant propagation do when you go back through a scanner and say you go to the global one here at these frefs? Well, you get the global value for the scan, which is the one for all possible scanners, which will never have a constant blank blank Q array or an index 3. It's the global common one. You need a private version because I've just made a new scanner.
It's a new one. New.
Ow, what hell happened there? That was weird. Sorry, say again?
Yeah, you need a new one for every instance, right?
Yeah, I need to make a new scanner type.
For every varying instance with varying properties.
And this new scanner type I make wants to have a peak field whose scan object in the function is probably the original global scan object. But the scan that I start with, no, then the scan I'll pass in when I inline peak, when I make the call to peak here, the scan I'll pass in will be the one that has the fixed thing. It won't be the global one. So I kind of want to close the loop here and make these cyclic. And then when I start inlining, I will effectively unroll the cyclic types. So I'm busy trying to find these things, find them all, chase them all down, and make a cycle out of them. And because of interning, it turns out, well, because it's a cycle and you have to close the cycle, you have to start by saying, I make a scan object whose skip and peak fields aren't actually filled in yet because I don't have the object pointer to start with. So I make a scan object, I put blanks in here. I can fill them out recursively. I fill out X. Oh, it's an int, it's done, buff, whatever. I get to skip. Skip says, I need a function pointer, but the one I have when I started the recursion points to this fref. So I want to clone this lazily, except when I find a scan, stop and pick up this pointer and replace it. That'll give me a closed cycle. Once I got the closed cycle, then some of these questions go away. The current failing I'm getting, by the way, right now, is that when I inline the call to peak here, the scan he's passed in and the scan that this type here are of different types because this one is a fully fledged closed object that knows what scan and peak is. And this scan object knows what X buff and skip is, but not peak because peak wasn't declared when I made this fref for the scan here. So I say, oh, I'm calling s.peak with a scanner that knows what peak is, and peak is a function that takes a scan that doesn't know what peak is. And these are different types. And so the reason to close the loop is so when peak gets called, he says, yeah, I'm a scan object. I know what peak is. So this scan here, this scan here knows what peak is. But I haven't defined peak yet. So there's a cycle and you have to close it. Okay, fine. And then, and that's where I'm floating around right now. I'm getting duplicates. I make these things, a new scan object in the intern table without the fields filled in. And then I collide against other things. So following that project recursively, when I make a new array object, this U8 is a struct with a length field and a byte array field. But it turns out I have one of those identical, and I don't want to make a new one. I want to find him, and I want to find the interned one here, and I don't want to, in the scan, I don't want to find a prior interned one, because the prior interned one is either one that doesn't know about skip or doesn't know about skip and peak. Or it knows about all 4. There's like 3 or 4 versions floating around in the intern table, and I want to make a 5th that's cyclic. Once this
This
piece,
sounds a lot like the problem that SSA solved with fees.
um, I hear you. So I'm solving this with graph theory because I have a closed cycle. And how do you find a closed cycle? How do you find a closed cycle? You're strongly connected components. I was trying not to go to that much theory for AA. I was looking for even simple. AA does the whole 9 yards here and gets it all. And it's actually reasonably quick. It's just a ton of code and it's kind of subtle. Why the hell are you doing this? At the end, it makes all your other things you do with these structures and functions a hell of a lot easier because you know that they just refer to the same thing immediately. You don't have to do any lookups. You don't lose information when you do the lookup at the global table. You can have precision versions where I have partially unrolled the types and the lead-in types are all known to be good valued things. Like a linked list where I push something on a linked list, then I pop it off. I don't know what the tail looks like, but I know the head has this thing I just pushed on, and when I pop it off, I'll get the thing exactly off that I just pushed on. And that's done in the types, and that means it's done in the value objects, which means I don't have to care about restructuring, looking for a push pop and a linked list. I can actually track it through the type system. Um, yeah, I hear SSA. So SSA has fees, and fees say I have a closed loop. I don't know what comes around the back edge. Yeah, okay. So that's a fair assumption. In the lattice guy, the since I don't know what comes around the back edge, when I make a call to peak here and you take some set of arguments, there's a hard call to peak I've just made. There is a default call to peak of all other people who might call peak in the universe. And that makes you merge scan objects from this one right here I've highlighted versus all the others. And at that merge point, I have a function parameter that's merging call sites, the unknown infinite, and then the known specific one with a known string. And then I do a fee function. It's a parameter merging. It's literally a fee function. And I then do a meet for the definition of how a fee works. And I meet these two. And then at the moment, I'm throwing an argument out of bounds or illegal argument, or the call site dislikes the argument. And that's related to not understanding. The call doesn't understand what a peak field in a scanner is. So the scan object getting passed in fails the is a test. Is a scanner? Well, you have to be something that has these fields, and you got these fields plus extra. And do I let that is a work? So he's complaining.
How about this keyword instead of a scan is?
Well, right. So the
So here my thoughts were forward ref is maybe too powerful because you're if you are at this pointer, you would know that all of referring definitions has to reach the end of the scan definition. So what I heard is that when the skip version here it doesn't know about peak. The peak knows about all the previous definition. It's kind of a refined version of the scan. Is this correct?
When I'm done with my intent or my goal is that it would be the exact same version as this scan here. This is the whole thing. This is supposed to be this whole thing.
But as the parsing progression, they're kind of different.
Yeah, during the parsing, they're different. When I'm done, I have built a graph and entombed in the graph in various places, various versions. I now want to unify all those versions and say, hey, wait a second, we now have the final set.
Yeah. So you do that as a forward thread. When the scan is discovered, then the forward thread will be replaced by the.
So in the nodes, in the nodes array, the forward ref gets replaced, not in the types. So I don't have a forward reference to scan going on in the code here, except in the types. But when I do, I put a forward ref object in, and then the forward ref object, when you close the cycle, he just peepholes away, and you've made a cycle and you're done. It's a interestingly variant of like target union find, disjoint union find set, right? I've just put in a leaf the leaf unifies with the correct name eventually, and then you just unify them together and pull them up and you're done.
If you replace with this, you know
Yes.
that you have to finish the scan in order to figure out what this means.
Yeah, then I have this problem here that when I get to S, it's a this type, which is undefined of any kind. And then the parser says, look up the buff field in the this type, and I don't know how to do that. So in AA, I'll make that delay perpetual, and then I'll clean it up with a stronger typing system. I'll actually come into with Henley Miller and hit it on the head and fix it. In simple, I'm actually saying, I know I have a scan object. Scan objects have a buff field. At this point in skip, scan objects have a buff field. This parsing strategy of one pass forward demands I put fields in order. I will allow you to be self-recursive, like factorial is, but otherwise you have to put them in order. Now, is that too restrictive for usable language? Well, for tutorial language, it's not hard to write the code this style.
Yeah, for a tutorial, I mean, it's the question, like, what's your goal? Like,
Yeah. Well, it's here you have to parse all this shit and do something. So the other version of this is to
you gotta
say
leave something for chapter 39.
the other version of this to say is build an AST, which delays all the questions. Then just like you said with the this, I have a something.buff. What the hell is .buff? Well, I don't know what the something is yet. Okay, when I close the cycle and rewalk the AST for the second and third time, I can say, oh, now I know what this is. It's a scanner. Scan.buff is well defined. Okay, and then life goes on. And then at some point after that, you go build, graph to do optimizations with. In AA, I actually throw in a forward ref here, and I let this go, get this s.buff go, and then it's a load of a buff field, but I don't know what buff is yet, and I'm okay with that. But to make that okay, I have to have the IR that I'm building be okay with sort of perpetual delay. It's a load of a buff field.
So why perpetual? Why only restrict to the definition of the object?
So let's go down here to this example I dumped down below. Struct A has a nullable B, a nullable C in some fields. Struct B has a nullable A, a nullable C in some fields. Struct C has whatever. So while I'm defining A, there is a forward reference to a B that I don't have a copy of B.
Yeah.
I don't know what the hell B is.
But that is slightly different, at least to me, because one is a forward reference to an unknown type, but this like this pointer is kind of reference to the self. It's the self type. It's slightly different. It's confined to the definition. It's confined to the definition of the A.
So in my head, these problems are the same problem. The resolution just happens at a different point.
Yeah.
You're saying the resolution for the this happens at the end of the curly brace on the A.
Yes, mandatorily. So it's a weaker form. It's a weaker form of the forward ref. Only valid for the scope when the struct A has finished definition.
And
at this point,
the solution to build CF nodes on the fly and have that solution work even at the end of scan would immediately give me the same solution for the problem I just did down here. The answer covers both of them in one pass, in one shot.
Cool.
Are you trying to keep this all single pass?
Yeah.
That's the goal, actually.
That has been one of the goals all along. It's a single pass recursive descent parser. And I'm okay with forward references. They're not technically a second pass. Now they're just incremental work on the graph and it's done. I could go what you just said, Theodore, and say, I'll just have a load of a buff and I don't know what the hell it is, where it's coming from. Okay, and I'll just delay until it shows up as a struct that has a buff field. And maybe I can just do that. I have some tests in the parser that say, you're asking for a buff, there ain't no such thing, and I'll give you an early error. And instead I would have to delay on that error, like you misspelled and you said, okay, it's a buff 2 or buff E, and then I would say, well, that's okay in the parser.
But either way, what are you doing with the forward ref? You declare a forward ref and you continue parsing because you cannot finish the definition.
Yeah.
And once you know the information, you'll come back here and you will resolve the forward reference.
Yeah, and
So
what's it mean to come back here? That's a second pass unless I come back in the graph, which gets what I did in AA, which is say, don't check in the parser. Buff is just a load of a buff. I don't know. And
mhm,
then when you finish optimizing and flowing types, and the types have settled out, this S better have a buff field. That's the field you're talking about.
mhm,
And that next means that buff pulls up a value that has to be an array because I followed you with an array syntax. Um, and again, all these things are checked at parse time, and I would throw all those checks away, and they would happen. I could go that route.
mm,
In some ways it's simpler, in some ways it's subtler. It delays every
yeah.
decision, every error. The program
In
could be okay
in
until
my mind,
I
if this is a forward reference, in my mind, you cannot optimize this because you don't know, you don't have the information. Once that forward reference is resolved, all of these nodes can go on the work list, and then can their chance to be optimized. So it's not going back actually, it's delaying the
yeah, it's
that.
a delay, but I'm changing forms. I'm not reading the text again.
Mm-hmm.
I'm now walking the graph, and the graph
Yeah,
should have captured everything.
yeah.
Okay.
So the
So
problem.
also in this version, by the way, I still have this problem because I'll still hit scan and have to make it a forward ref in the types,
Mhm,
which is fine. And then I solve this at some point doing this.
mhm.
By calling here, when I call here, I mean I make this type and then I do effectively make cyclic type step here.
Yeah.
Um, yeah, I could go that route.
Mhm.
This would allow you to reorder these fields in any order. Like as a one
Yeah.
pass top down tutorial, it's very
And,
obvious how it
and
works.
it's actually there won't be different versions of scan while the parser progresses. It will be only one forward reference of scan. That's my I maybe try to hint that the
Yeah,
compiler knows
right.
that it will be a scan by the end of definition. It won't be anything else.
Well, so I need to have a placeholder in my hand. So what you get is you get a known forward reference scan, and I'll just not bother to track what his fields are. Right. So I used to have this pattern, just what you said. I have a known forward reference, and I don't know what his fields are, and I don't care, and I ignore it.
Mm,
Then I have oh, see you later, Cameron.
mm,
Then I have then I said, okay, wait a second. Let me see if I can't. I didn't have any types, didn't have any fields, and I couldn't parse this code because the parser would say, there's no buff field in this guy. If I throw
mhm,
that test away, well, then I hacked the code and said, I'll add these fields incrementally. So you get these three versions. You got scan with nothing, with X, with buff, with skip peak, and you get four versions in a row, right?
mm,
And then there's a
mhm,
closed off version that says, I'm done. Instead, I could just have the two, which is the first one is it's a scan object. I don't care. I don't know. I don't care. Don't test. So you walk through this shit here. It's a buff. I don't know. It comes from a scan. Scan has no fields. It's a forward ref. I'll assume correct. Go on. What is the type of loading a buff? I don't know because I don't know what buff was. So
mhm,
I'm doing an array reference on buff. Oh, maybe it's fine. Don't check. Don't ask. Don't check. No more checks. Just put in the array load. Okay. So then you get down to the end here, and when you close it, you say, okay, the scan that I had floating around as a I don't know gets
mhm.
replaced with a here it is, the
And
full
then
blown thing,
yeah, and then the
including
actual
cycles.
optimization starts. Then the actual optimization starts because all of these
Yeah,
nodes can go on the work list and because
yeah,
they know what they're talking about.
right.
So yeah, in this sense, forward reference and the this type is actually the same thing, but I'm trying to see if there are benefit to know that the this type will only be valid for the definition of the
I
scan.
hear you, and what I'm saying is it still makes no difference as soon as I handle
Yeah.
as soon as I give up doing the error checking in the
But
parser
that's
and
the
do the error
simple case.
checking
But
later.
if later comes some type B, you don't know, you have to put a forward reference. But that would be delayed only because B is defined somewhere in the end of the file or in
Yeah,
another
that's
module or
my
something.
example down below is exactly trying to show I don't know what the hell B
Mm,
is until
yeah.
far later. And the solution could and should and is the same.
Hmm.
Delay, don't error check in the parse.
Yeah.
Just gather the syntactic elements, turn them into nodes. you can put them on the work list. They just have to say, oh, I don't know what my type is. I assume it's okay, but I'll just return a bottom for the load. Load of a buff is a bottom, and it's okay, and carry on.
Mhm.
And then you get off the work list until such time as your pointer input sharpens to a known scan. And then you get back on the work list because you changed your input type from an unknown scan to a known scan.
Mm.
Now you only have two types. You have an unknown and a known, and at some point the unknown ones should all get flushed out and replaced with known ones. Um,
Mhm.
and then the load will show up on the work list again and say, "Oh, I know what a buff is.
Yeah.
Here you go. It's an array," and life goes
Mm.
on. That also means like the scaling here has to be disjoint because I don't know the length of the elements in the buff and stuff. There's a bunch of delays have to happen here, which could happen.
Yeah. So
When I
I
hear
don't.
that, I start to worry about making sure you have something that's going to break you if you have an infinite loop of I stick the thing on the work list, I pull it off, it's not done yet, I stick it back on, I pull it off,
Yeah,
it's not
Mhm.
done
yeah,
yet, I
yeah.
stick it back.
That's
Well, you don't
that's
put it back on the work list unless something changes.
you have to guard that in a graph. You can end up in a cyclic definition because one of the definition depends on the other, and
Yeah. And what
that can
goes
happen.
on down here is I get all these cyclic definitions.
Mhm.
And I can't do a one pass within I closed scan and I know everything about it here.
Yeah.
Because if I've passed a B object in and I want to take a B field, I don't know what a B field is, so I can't
So
define this function.
okay, okay. Well, let me see if so if this is, let's say it's a this type, you don't go the forward drift type.
Yeah,
As soon as the end block, as soon as the definition block here ends, you know that this type is already defined, and
right.
automatically all of its definition go on the work list.
Yeah, yeah.
So that because for a it's the same for the forward drift actually.
Right. So to do this without any effort or thinking,
Mhm.
I build a constant node that refers to the constant, basically the constant class for scan.
Yeah. Okay.
And then it's given a forward reference type, and all these people are taking the forward reference type version in,
Mhm.
and then the constant lifts to the unknown fields become known to be an X with an int and buff with an array and whatever the fields are. And that's a lift in the lattice. You have to define the lattice that way. But now that's a valid lift in the lattice. Users of this constant go on the work list because you just changed the constant's value.
Hmm.
And that's all normal part of the machinery already. So I do nothing for that one to work. And it would get this here. The only trick is I still have to deal with make cyclic at some point. And this version of make cyclic, what you do at the end of a struct definition works for a struct alone, but doesn't work for self-referential structs like I've done with ABC here. Like I have persons and they have employees and they have contractors and they have family with children, and persons have references to children, which have references to parents, and they're all cyclic types. You can't get them except running the make cyclic type thing on the collection as a whole,
Mhm.
which delays not to the end of the struct, but to the end of the compilation unit.
Yes.
So I am currently doing this at the end of the compilation unit. I haven't decided to
And
get
still,
rid of all the testing and
the chance for so yeah, I'm still trying to think. Are there benefits to the this type or just for
I think as
forward
soon as I
drift?
go to the this type, I declared a forward reference. I think what you're really saying is I'm going to give up testing and I'm
Yeah.
delay in the parser.
Mhm.
And the parser gets simpler. It just doesn't bother to test. It just gathers syntactic elements together and puts a node out for each syntactic element. So that's great. Then I have to gather error message data because if you've misspelled buff and no buff ever appears because you've spelled it wrong, at some late stage in life, long after the parse is done and while I'm optimizing, I'll come around and say, I take in a closed known scanner. It doesn't have a buff with two Fs field or whatever, however you misspelled your buff field.
You have to delay because you don't know. You have to
Yeah,
assume that
yeah,
that
right.
something will
So
happen.
right here, like if I move buff to the end of the struct, because I like my fields at the bottom, why do I care to have them at the top? Is this valid? Well, right now I have to say no in the current strategy. The new strategy you're talking about, I would just ignore the problem.
Mhm.
Of course, if somebody else came along here and they misspelled X for Y, and Maybe there's a Y. I don't know. I haven't hit the bottom of the struct.
Mhm.
So you say that's okay. Ignore it. Carry on. Now you get a big old pile of nodes. There's no graph. There's no graph. There's a graph. There's no syntax. There's no text. There's no program text. And you optimize, and somewhere along the way there comes a load Y, add one, store Y. And then what is Y loaded from? A pointer. What's the pointer? Well, it's a scan thing. Scan doesn't have a Y field. So that has to at some point, which is fine. I mean, it just delays the error. Error goes on the load, and it has to go when I know that I know. Like if I have an unknown scan and you say, is there a Y field? The answer will be, I can't tell you.
Yeah.
Right now. Yes.
Yeah,
Hmm.
go ahead. I'm thinking, I mean, maybe this is the
Yeah.
right answer. It's a bigger change than I wanted to do here.
So that would be only delayed by the end of the struct definition. So you cannot end up indefinitely.
It's already too late for the parser to put out a error message locally. So I have to record everything that I'm going to error on and print it out later, which is fine. I mostly record that data already under the theory that I was going to do something with it.
But at the expense that you have to keep track of many more things.
You have to keep, the character offset at parse time. I have the, pointer to the whole program text that's lying around, and I have a pointer to the parse area, the Y field here.
I
And
was referring to that you have to delay all these things in order
everything here has to be, all errors have to be delayed. I'll assume I'll collect, I can stop on syntactic errors that are just invalid syntax only. If it wasn't a syntax error, it's a semantic error, I can't test. Fine, I can't test. You delay, test later. Okay.
And in theory, you could leave things like that lying around. Let's say I had two functions that call each other with mutual recursion.
Yes, that's one of my fun examples for
I
A.
can define the first one and then do a bunch of REPL stuff that you should be able to interpret just fine because I don't call it, and then define the second one and then call it. And as long as I don't call the thing that has the forward reference in it, I'm not going to be stuck saying I'm not going to execute anything else
Oh,
until the
you're
forward
saying
reference is resolved.
yes.
I can keep REPLing. My point is I can put a REPL command in the middle. What happens if I put
Yes.
print world between the definitions of even and odd?
Well, okay, so in this model down here as a REPL, you print, then the REPL says is even is a definition of the variable. It's given a function. That's the execution. The function's just a constant. It's a pointer to code in memory. So when you execute the pile at the bottom, it says is even. I'll set a variable. Done. No side effects. Nothing visible. I print hello. Hello comes out on the REPL. I set is odd. I do is odd. Great. And then I come through in here and I say is even of 3, right? And I ask the question, ask the REPL the question, what is even 3? And the REPL should come back and say, oh, false. We can pretend like we just ran a REPL through. So there's nothing on this one here. Right? This
And
kind
if
of
I
a REPL.
call is even before I define is odd,
Yeah, right. Okay, so let's do that.
then that should throw an exception?
Yeah, you can say for reference. So here I'm in a REPL, and I said this is even 3. This should, instead of false, it should say,
Error is odd is undefined.
yeah. And then you had the argument that you could say, what if I call is even of 0, right? Does it print true? Does it claim I don't know how to build that function, so I'm not going to let you do partial function evaluation? I claim that's
I mean,
that is
arguably you could constant propagate your way through it.
quality of execution, quality of implementation. Do I want to let this happen or blow up on you? I kind of don't care at that point. At least not right now. The quality implementation says I'm going to interpret every partial thing, and if you never touch is odd, don't blow. In the land of Java, the moral equivalent is if you name a function, if you name another class, but you never cause the class to be initialized, the class doesn't have to load. So if I have my own class, and in this class I say I have a function called, uses people, and it takes up peoples, but I never call uses people, then the VM knows that there is a people class, but he doesn't need it loaded yet. And if you never actually have one on the class path, he doesn't stop. He lets you run on.
Yeah, that's where I tend to want some kind of distinction between lenient mode and strict mode,
Yeah, right.
where I can be like, for the purposes of you at the REPL developing the things that you're developing,
Right.
yeah, this should execute because it's probably giving you some information that you're going to use to write the rest of your program.
Yes. I mean,
But I also kind of don't want you checking code into the main branch that has dangling forward references in it.
uh-huh. So like
So I
there's a
kind of want something that says, hey, when I'm REPL my way through it. But when I say, hey,
like
AOT compiler, actually go through and check this whole
close.
thing for
So I could
whatever your linting
compile,
process is.
yeah, I could
Like,
compile is even. He'll have an open reference in the elf file to is odd that's not yet been linked against.
right.
Right.
I think there should be warnings that you
Yeah,
can
at least
run
a
as part
warning,
of your
right?
build tools that say,
Yeah.
hey, when you build this thing, you have undefined forward references in it. No, I'm blocking your check-in to main. Stay on
Yeah.
your feature branch
That
until you
that's
don't
a
have
right.
undefined forward references.
That's a different thing, and kind of unrelated to where I'm at the moment. The problem I'm fighting right now, I'm listening to Theodore say, just give it up on the parser and just make a big change to the parser. Give up all the error checking here and go lenient all the way through, and then these problems would get resolved at a later time.
I kind of feel that's the right way to go. Let the parser just kind of accept whatever and then figure out the errors later.
All right, there's
I,
another vote.
yeah, depends. Yeah,
Yeah,
depends on what stage. Yeah, really.
Chapter 23 is going to get a big ass change for this one.
the specific scar tissue that I have there is trying to write things where I keep commenting out and commenting in blocks of code because I don't understand what it's doing and I'm
Right,
trying to do some debugging.
right.
And Golang compiler says, oh, you have an unused variable. So I
Oh,
go comment that out and it says, oh,
oh,
well, now this variable's unused. And I go comment that out and it
yes.
says, well, now this variable's
Oh my
unused. And
God,
it's
I have
like,
fought those.
why am I going through 6 rounds of start the compiler before
Yeah,
I can learn this subtle thing?
right.
And what I actually want is like aggressively running mode when I'm developing, but I
Yeah.
don't want aggressively running mode when I'm in production. I want to know that it's not going to throw on me.
All right. I hear
So
you on that one.
I guess one solution to that is you can just have things like, can any throw reach main?
Ah,
And be like, hey, I'm running in no throws should percolate all the way up to main
I have
mode,
a
and
I have
every
a
throw must be caught somewhere.
I
Well, if
have
I can
a
turn that on and off, then the fact that this throws when there's some forward reference.
I was thinking, why do we have a forward? Has to be forward reference
well, okay,
because
so yeah, there's
so
two different things
hold
here. I don't have
on.
any exceptions going on. So Aaron's question's easy. I don't have any exceptions going on right now, so I'm ignoring the problem. But there comes a point when
Okay,
I'll have to pay attention to that one. And I'm
okay.
with you on the unused variables should not be an error. At most a warning, but not an error. And then for Theodore, this program I wrote is written so that I don't have this object's implicit yet, but I want to
But
write something that passes the existing parser. So there's another version of this where I'm going to take
but
this whole code and just code block dump a new version where I turn it into a method. And that will have an implicit this, and I won't have to write the word this. and I'll just, we took all our code blocks, or I have to make a new code block.
I was thinking why it has to be a forward reference
It
here.
is. Any Java program on the planet, C++.
But you know already the scan. You haven't finished the definition of the
Yeah,
scan.
right. So
So,
at this point, scan is a forward reference. I don't know what it looks like.
but you know it's a struct.
I know it's a struct, and I don't know
Yeah.
what it, that. Yeah, yes,
You,
that was the state of the world I had until last week. I know it's a struct, except that
and
I am now trying to write this code on the inside of the scan object. Last week, this code was not valid because I couldn't put val skip equals takes a scan inside of a scan. It would
Mhm.
simply say, can't have a forward reference here, you're dead. And the
Mhm.
parser would just stop. So new
Okay.
this week, I can put a reference to scan inside a scan object.
Yeah.
And then I hit these other cyclic type issues that I'm
Because
sorting.
it's not finished, you have to just delay that
Yeah, right.
resolution inside here. So
Yes.
you say some kind to the parser or something. You just don't put anything on the work list here because we didn't finish the scan definition.
Yeah, the work list is a red herring, so I'm trying to say with that piece. It doesn't matter if you go on the work list or not. So just
Yeah,
ignore the
yeah.
work list issue. It's
Okay.
clearly you're not done yet. You're not going to make any progress, whether you went on the work
Mhm.
list or not. Okay. So new this week, I said put this code in, allow this to happen. Then I hit the problem that I couldn't find a buff. Then I said, okay, I'm going to force you to code in order. So you have an X and then a buff. And now I have a scan with a buff and an X, but then I get these versions. At this point, the scan object knows about X and buff, but not about skip. This scan knows about X, buff, skip, not about peak. And the different versions were showing up at different call sites and then complaining about I didn't understand why you had different fields. And I
Mhm.
said, okay, I have to close the loop on the cycles. And I hit problems with the interning issue. And that was sort of the end of the week. Now, is this the final syntax I'm looking for? No. And do I want to delay everything out of the parser and deal with this problem, later when the types are solid? Maybe that's a good answer. And then what I'll do in the parser is say, this scan is at most a scan. I know it's a scan, it's a struct, but I have no idea what the fields are. And I'm not going to error on that. I'm going to say, hope for the best. There better be a buff. If you're Henley Milner, I would force you to say, you must have a buff right now. And I know it's a buff of an array. And then Henley Miller does things differently. In a forward flow, I want to get to the end, close the looping cycles here, and then run the optimizer a while. And then he'll come around and say, oh, you in fact have a buff field, and it has an array, and so you can do an array lookup on it, and blah, blah, blah. And he'll do all the right types. So I think, I don't know. I guess I'm going to sit here offline and ponder,
So
but
if you are Hindley, you won't have any type here. So anything
yeah,
is valid
right,
as long as it's discovered. But right
right.
now here it dictates that it's a nominal type, so it has to have a scan here.
Yeah, yeah.
So going that forward, the only choice without allowing this is to delay the dot buff
Yeah,
resolution
yeah,
at
which
the end
means
of the
delay what you did with the buff, including calling other functions and passing it as
yeah.
a function pointer to
Th-
other
th-
functions and
th-
all kinds
That
of
that
it's just delay.
that can turn out into a slowdown into the optimization path or something because you may end up to delaying too many things at once. I don't know if that can
I'm
be.
okay here. This is one of these things where, uh, in the land of C2, I was reading bytecodes, which had all this hard work done already by Java
Yeah,
C. Now we're
yeah.
also doing the Java C work
Mhm.
along with some optimizer stuff. I'm okay. I'll give it up. The three repeated references to S will get commented up. The S.X will get commented up. Those are going to be two loads to S.X that'll get commented up, but I can't do like +1 without knowing that you're +1ing on an integer or a float or something. I mean, a lot of things stop because I don't know. But
Mhm.
that's fine. You don't. And when you know, you'll know at that point.
Then I believe this can work like like we are saying that way by
Yeah.
delaying.
Yeah. Now, syntactically, let me see if I can cut and paste here. What I'll do with methods will be a little different. Yeah, that worked. I'm debating whether I'll have nothing here or at most a dot that says I'm a this pointer. And then I don't need the S dots because It's a standard C++. Yeah. Do you really want a dot here?
No, so if you can just keep the when you refer, you have to check if you have the definition on
Oh,
on the
that
scope
gives
in the
me
scope.
a, ooh.
Mm.
Right. Okay. So when I come through here and I say I have a buff
Mhm.
and I have this up here, uh, which
That
buff am
shot
I referring to?
that shadowing, and anyone can figure out that the inner
No, at the
between.
time the parser's in here, oh, he just says
It's
I have a
like looking in the
single.
scope. It's like looking in the recently defined scope. You
No, no,
put
no,
the
that's not
dot.
the issue.
But if there's
Yeah.
no dot, it feels like you want to have a function that doesn't take anything. If you have a function that takes the context you're in, I kind of want.
That's not the issue. Suppose I have the dot. I know I'm a method oop. I'm taking a this pointer.
Hmm.
I don't care how you decided. I know I'm a method. Okay, now I hit buff in the parser. Parser says I put a load in of a buff field. Am I talking about the one from above or the one that I can't see yet because I'm in the parser and I haven't seen what comes next? And the answer has to be he can't tell. He can't do anything about it.
So the Java answer here would be this dot buff. So it would be dot buff. That would disambiguate that
This
you
is
are
yeah, but it's
getting.
not necessary to write that in Java either. Java
Uh,
says the same thing I'm
oh
saying
yeah.
right now. The buff that you put in here is delayed as to which scope it refers to. I don't know the scope yet.
Yeah, it feels like the minute you put that dot in there and say, I'm grabbing all the context from my parent, that you can't know what any of that stuff means till you see the close bracket.
I'm sorry. The dot has not the outside context. The dot was me saying it's a this.
Mhm.
I'm
Right?
assuming I always have context from outside. Yeah, somewhere above here I've said I've got some other thing here. This is my arg. I got passed in. I'm inside of a main. I got passed an arg. This is all nested inside. I have an arg field. Is it in scan? Is there an arg
Right. So
down
you know
here?
the buff didn't come from the caller because buff is not explicitly listed in the args.
Yeah. So buff didn't come from the caller. Now, what
The only question
scopes?
is it new or is it from the context?
And what? Yeah. What scope is I'm inside of? I'm inside of scan. It could be a scanner from a buff from scan. I'm inside a nested main. It could be from main.
And if you had written let buff or var buff, then obviously it's local.
Yes, I didn't.
And
I
if
didn't make, I
there
didn't
is
make a
no
local
let,
definition here, right?
then it should be coming from the context.
There's a third. There's your. I don't care about let, but buff equals 99, whatever. There's a local version that didn't happen. So when I'm parsing and I look at the word buff and I hunt, I can't tell that I should find it in scan or not, or I need to keep going out of scan and up scope.
Right. I look at that and it feels like the buff that is inside scan that has not yet appeared
Uh-huh.
is what it should be, and the
Yes.
buff that is outside of scan is wrong.
It should be shadowed.
Mhm.
And the
But you
buff on the
can't
outside
possibly
is
know
just
that
saying
till you see the close bracket on scan.
I'm claiming right. So then this becomes the parser says I'm going to say that you're a buff from a scan maybe, but at the time until I fully complete scan, I can't tell without going back now and saying I found you, so you're correct or you're not. So go up scope,
Yeah, it's
and
worse
I
than that.
have
It's
those
a
scopes.
you're a buff from literally any scope that's not being done, being defined yet on the whole stack of scopes.
Yes, exactly. This is
But
the problem.
but we
So if
are
I do
missing.
nested class definitions and they have
Hmm.
scopes all the way
Yeah.
down the line,
Yeah.
yeah,
Hmm.
yeah. Just
And if
like,
I allowed you to do wildcard imports, it also could be in any of your imports.
Yeah.
yeah,
That's why it's bad.
yeah,
But
right.
here we have to take into account that this it's introduces its own scope. So it has to find it. So it has to find
No,
it
no.
inside
Why does buff not? Well, why does it have to be a buff down here? Why is this code not just legal right now?
because it
Why
cannot
is this buff
resolve
up
the
here?
so Okay, that's the next scope in the file scope, if it's
Yeah.
or the main scope. Or,
Yeah, the main scope. Yeah, indentation didn't happen because,
Okay.
I'm stupid. This thing doesn't have an indenting mode here.
So what would Java does here? I don't
For
know.
nested inner scopes, he says you
Mhm.
can shadow. It's okay.
So which buff would be picked? The scan or
Well, this one,
the
there's only one buff in this program, the one on main.
so without that, if you have two buffs, what
And then
Java
he
say?
takes the inner one. He says, I take
Yeah.
any definition, take the innermost definition, but the definitions can be out of order. So go find the one at the bottom eventually.
So the next scope that is from outside the skip wins because it's closer. So it's contextually more relevant to the skip
Okay,
than the
that's okay. So this is known as to how you resolve it.
yeah.
You're shadowed or you're not. You take the innermost one and
Okay.
definition.
Okay.
At parse time, when I run across buff, what do I build out of graph that says I am a load of a buff field, but I don't know if I'm loading from scan or from a local variable on main.
So okay. So at this point, the parser should decide what the buff means. So if it doesn't see in the buff down
It can't
here,
have
so
seen what's come next. Cannot.
yeah, but it has the buff here.
Yeah.
So that would conclude if the first definition seen should finish this definition, or if later by the end of the scan definition there's another buff should be rewritten. But that is complicated. So I
Well,
don't know.
that's exactly where I'm at. At the time I parse buff, I see the one above. I know that I don't know about all the nested scopes I'm inside. So we're only one nested deep here. Suppose I'm inside 5 nested inner
Yeah,
classes,
yeah, yeah. Mhm.
right? These is arbitrarily deep nested inner classes.
So either you have to track the scope, and you say I don't. Parser would say I think it's this buff, but if there is another buff later that is in the most is it's in the inner scope of that buff, then that buff should be the definition of this buff.
Yeah, it's
So
just
that
an easy way to fall into you can't do anything till you see the close bracket of
yeah.
main.
So yeah, but
Yes. And is
but
there
that
something
but
right?
that is limited to the fact that the
Well,
parser has to make that decision right here,
can
right
I
here.
emit graph at all?
Hmm.
Or do I have to parse it all once to get
So
all the list of
it
names
would
and then
it would
parse
have
again?
it would have to emit the most inner buff definition, and it will have to track when you introduce that buff definition, then it will automatically replace because it's the most inner one. But that seems just too complicated and error prone. So I don't know.
Right. So there's a thing that I do now that's related that I'm trying to figure out if there's a saving here, and that is if you make a variable and I don't find it in the current scope,
Hmm.
then when you pop that scope, I promote that variable. Let me show you an example here. I'm going to scroll down to is even and is odd because these guys have it already. Oh, but we did our little fun games here. I'm going to replace this back to is even is odd, and we'll just see the same exact thing because while I'm parsing is even, there is no is odd, right?
Hmm.
So in the parsers come along here and he says, I'm parsing is even. I hit is odd. I don't know what the hell it is. I put a forward reference in. Okay, that's my forward reference node type. Then I come to the end of the scope. I'm down here at the last close curly, and I'm like, oh, I never found what is odd is. So instead of being an error, I'm going to promote it to the next outer scope as a forward reference. Then I'll come over here on the next line down and eventually say, oh, I found an is odd. It's currently defined as a forward reference. When this is done parsing, I have the forward reference. The is odd is a variable defined in the parser scope that is pointing to an is a forward reference node. When I get a definition for it, I'll fill it in and say, that's the one.
That would work, but if in order to make that workable, the promotion has to be bound. So only one scope up, or only
No. You
two
can
scope
go,
up.
no reason it has to be bound and no reason why it could be bound here. But it might work
So,
here.
but why? You can end up in a situation that you endlessly promote unbound symbols. So
Until they promote to the outermost scope. And then I say, you never
okay,
define
in
buff.
in 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 that case, you delay to the end of the compilation unit to
Yeah,
resolve that.
yeah. Somewhere at the end of the compilation unit, I say you never define buff,
Mm.
and so you get a
But you have
compiler
to
at that
track.
time.
So errors will become more harder. So you have to track
I
where
have to track more. Yeah, there's something going on here. Yeah, there's some
you
confusion.
have to track where the where the definition where the use is. So
Let
in order
me.
to
Oh, you do
report it.
that. Yes, you have to track the uses. And no, I'm tracking the uses now. The uses are the load node that I would put in. So here's a proposal. So when buff gets found here, I'm going to act as if I put some forward reference buff in. Oh, I found a buff. Oh, I think it's in the
Mhm.
scope. I'm hoping.
Yeah,
If I get a definition for it, I'll just update the forward reference. And if I
that
don't, I'll
was
push it to the next outer scope.
that was I just said 10 minutes ago. You track and you find more inner buff, then you replace that. So you treat it as a forward reference,
Right.
like you
So my
said.
Yeah.
question is, why didn't that forward
But
reference end up much further up?
Well,
so
at the
It should
time,
be inside of the skip function and maybe inside of the while block.
it would. No, it would be this. This is the innermost scope while I'm doing the while. While I'm doing the while does not introduce a scope. It's just got an expression, and then it puts a scope in the body, but I'm not talking about buff in the body of the while. So the scope you get is the scope for here. So the first buff I would put in is the buff at this layer.
Right. And when you get to that closed bracket, you have to promote it.
And then I promote it once to this layer.
mhm.
And when I hit the definition at the bottom, I'll close it and I'm done. And that's the correct layer. If I don't, if this doesn't exist down here at all, then I'll promote it
Okay,
again one more
that's
time.
a better plan than mine because it will automatically promote by the end of the scope, and this is a
Yeah.
good plan because
Maybe
because
this is all a red herring. It was always going to work.
yeah, so I believe that would work, and because it's implicitly following the rules that the innermost scope wins.
Yeah.
So yeah,
All right.
that
Wow.
that's
Okay. So now I'm
And
that's
back
as
around to
long as
thinking
when
this
you
works.
first created that node, it knew what file and character it's coming from,
It does.
yeah, but you
even
have
though
to
the error happens when you close the brace on
you
main,
you yeah you
it
have to track.
knows that it's not actually talking about main.
You
I
you
do.
to have to track promotion here.
Yeah.
You have to track promoted variables
You
in
just need to
order
make sure it
to
doesn't lose
report.
its identity at each promotion.
Mhm.
It doesn't. The forward ref has a where in the program text I came from, and that's just part of his private final info. I came from
So
this point, those three characters in the program text, including the line number and surround and whatever, enough to make an error message out of it. And then you
So is
get
so
that bookkeeping bad? It feels like that's not the worst bookkeeping you've got so
no,
far.
it's not. So maybe no. This might be the right strategy. I
mm,
started with saying, okay, this is different. It's big different. There's a lot going on. But maybe, and I have sorted some of these problems in the past already, and I'd forgotten about the promotion thing I was doing already for
mm,
is even is odd work right now, and that's done with this promotion thing. And it was specifically for this promotion thing, so this should work too. Knock on particle board.
mm,
Maybe it all works.
Because
mm,
that's the thing I tend to think of with forward flow typing is you just I'm always asking myself, what would the REPL do?
mm.
Ah,
Like,
yeah, it
can
puts
I
a
get
puts yeah,
execution right here with things in
yeah.
partially broken states?
Right. He'll put a delaying spot in. If you
But
ask for buff while you just got a buff use, he'll say, I don't know what buff is. But if you delay
Right,
long enough and you get a buff, then
right. If it manages to clean up before you call it, you win. And if it doesn't manage to clean up before you call it, then
yeah.
you
I
try to
sense
dereference a forward reference and you get roughly the same kind of thing as if you try to dereference a null.
Yeah. Yeah.
It's
so
just hey, you had a forward reference, you tried to dereference it. Here's your you tried to dereference a forward reference error, which might make your is even zero work fine because it never actually gets to the point where it
Yeah.
needs to dereference
If I'm
that.
executing in a REPL as opposed to trying to generate code. Yeah. All right, Theodore, you're trying to say something.
let me remember. Oh, so I think I sense a problem with not a problem, a complication with the promotion because even though that it's technically correct, I you have to take when you define the scan, if it's referred to the outer buff, wouldn't have to be when you define the scan. So wouldn't that buff when you define here a new scan? So what would be buff here? It,
Okay.
it it automatically takes the outer scope, and I
No,
don't
it doesn't.
think
No.
so.
No, as soon
Why?
as I look up buff, I have to stop and say, I'm not looking up in the scope. I don't know where buff comes from.
Okay.
It could still happen in a function scope, you have to declare in order. So in a function scope, the type of the scope matters. The function scope, I know that if there's a buff in the scope, I can find it. And that would be true of nested function scopes as well. If I don't find it and the next outer scope is a struct scope, now I don't know. And so I'll put the forward reference on the scanner. And if you declare it there, you do. And if you don't, you don't. But I won't go out of the scan to go up to the next function scope.
Yeah. That was my comment. Actually, you have to bound the promotion to some
bound, yes.
significant points, like the structure here.
Yeah, it has to be bound right.
It would be really error prone if the buff is allowed to escape its promotion to the outer scope here. So
it has to stop, right? It has to stop there. And then the stopping means I put a forward ref to that buff in that scanner, because when I call peak, he also makes a forward reference to the same buff. So he has to agree that he's seeing the same buff that the skip is seeing.
Yeah.
And then it turns out that's what you want to scan.
You're saying the propagation is stopped because the new scan call has buff in it?
No, I'm saying the propagation stops because struct scan right there is a struct definition, stops all propagation because there may be more fields added to the struct toward the end of the definition. So it stops right there. What happens down here with this buff is syntactic sugar that says I'm initializing the buff field in my scan object. It's not making a new variable at all. It's initializing the buff field.
Right, but if scan didn't have buff, wouldn't buff just be a global buffer in main?
I'm sorry, which one? Here? Down here?
If we don't have buff, so that buff should be resolved to this buff, and and here, if you say in another scope new scan, then where buff is coming from. So it's out of the main scope. It's in a different scope, and you say new scan, but that scan was fixed to this buff, to fix it to this buff resolution. So if it's a function, then it's
right. It should be the scope where the function was defined, not the
that
scope where
was
the
what I'm
function
trying to
called.
say. So by the way,
Isn't that always true?
Leaf shouldn't allow struct definition inside of the function, but if it's a outer struct scope,
no, it's just that the functions that inside of the struct have closed over that. That's just a closure.
Exactly.
Yes, it's a closure. Yeah, but and it's technically has to. It's bound by the main now. The main.
Yeah. So a bunch of things were said here that I kind of like don't disagree with, or sounds like confusion going on.
Okay.
In this scan with buff being commented out, this reference to buff is in fact the one that got closed over. It's this reference up here, and it's a closure. And I need to have the main function has to have a buff field in it that this guy is. So it's totally legit to have a structure defined inside of a function. That's totally.
Okay, it's fine. You can still define the new scans inside of the main function. Okay.
Yeah, inside of main I can define new scans, right? In order to not have to do true closures in simple, I am limiting the buff here to being a final field and scan objects here being declared inside of main, so that I can find my buffs by a simple field lookup thing. The same as Java lambdas. There's an easy answer that I'm taking the easy answer on. Fine. There's a more complicated version where you do some stack things, and then you have true closures where you have to allocate stack frames on the heap, and I'm not there. And in this version of things, the constructor call allows arbitrary code. If you name fields in the constructor, you can set final fields in a constructor. So the unique thing about a constructor syntax is that it allows you to set final fields that otherwise you can't set a final field.
Yeah.
Without buff being declared, this is a reference to this buff, and it's a local variable. It's not final. I can reassign it to a new string, except that this car array is not an int array, so this will give me a type error if car array is not an int array.
So here buff should be allowed to be promoted. So it should be allowed.
Yeah, and buff would be promoted to the outermost guy, and I would be doing an array lookup and asking, is an array value less than a car value, which is perfectly fine, and he would accept that syntax and life goes on.
I think that should work.
Does that answer your question there? Right. So if I
Yeah.
do this, then now these two buffs refer to this buff, and this buff also refers to this buff. And because I am a field in a struct, I am final by default. And so I have to be able to assign it in the constructor because otherwise you can't assign to a buff. So that's the constructor syntax that lets me assign a final field. In effect, I have a named constructor, an unnamed constructor, a standard default constructor that lets me name all the fields. But I just wrote arbitrary code there, and you're allowed to set fields. You include the scanner's fields in your scope when you're in this code, and you're assigning buff. So is that good syntax for constructor? I don't know. We can argue different syntax for constructor, but that's
It's workable. It's workable syntax. So
workable at the moment. Yeah.
What about adding a explicit like self type?
I don't do generics yet, so I don't need a self type yet. So it's like subclassing and generics want self types.
Yeah.
When I
Yeah.
implement this shit, I stare at the self types and realize that they're obnoxious. I've used them and they're kind of obnoxious to use to the point where you just throw your casts in and you're annoyed that you don't have an easy self type. Getting to generics and subtyping, yeah, there's a discussion about let's have a self type. What does it look like and how does it work?
What about explicitly naming the this or the self access instead of having,
Right.
instead of doing looking up buff, then just having this dot buff all the time?
I find that people use the this way more frequently than is necessary useful, so I want to punish them. And can I arrange that you don't need to say this, that you can't say this, cannot, you don't need to say it, but you probably need to say it at some point, and maybe I'll change it to the word self so that it's not Java-like, but then you get a keyword. Pick another keyword.
It makes sense. It's a self reference, right? So self is
so this
this reference. I mean, it could be,
right, but then should I tell you that that's illegal syntax because it's not necessary? Don't do it. Then you have the whole constructor thing where you pass three args and they're the same arg names as the fields. So you end up saying this dot field equals arg, this dot field equals arg. And I find that it's just like, oh, come on, guys. Get your butts figured out. That's stupid.
I mean, I know we talked in the context of AA about having dot be the context you're in and then just letting you destructure stuff.
Yeah, that's what I'm looking at here. Like, do I want to have you pass it? This would be symbolic or syntax sugar. There's no, I wouldn't parse the dot as anything meaningful except saying, oh, you're taking a hidden this pointer. But I would claim I'm inside of a scanner. You're taking a this pointer, period.
But how would you distinguish that from a thunk, from zero argument function?
I'm not allowing you at this point to write a zero arg function.
Well, if you access it with like a s dot peak at the end there, then it's implicit that you're going to be
but he's right. But maybe I want to have a function typed field taking a no arg function or a one arg function, but not the this pointer, static function. In Java, you have static functions, right?
Yeah, you want to be able to construct a factory or do a factory function, right?
Right, yeah.
So I know C++ has ways that you can specify, these are my list of arguments and these are the list of things from my context that I'm closing over.
Yes. And that's
if you don't require them to have a dot to say, close over things in my context, it is tempting to add syntax that enables you to say, I would like to explicitly list the things to close over. And by the way, that's the empty set.
Well, I find that syntax in C obnoxious. So there's two different things here. So Theodore's statement is correct. If I don't have any syntax, you can't write a no arg function here. And if I demand or allow, say, a dot, then I can say the dot means you take a this pointer or self pointer, and without the dot, you don't.
By the way, there has been actually some recent research doing this in Scala, where they basically introduced capturing types and then try to infer what was captured And they do actually make quite a lot of use of this. So I think in the end, you need to know this kind of capture checking in your compiler, especially if you would like to do some kind of either optimizations of or type safety checking.
So I'm not doing any Henry Milner here. That was kind of a design goal for simple. Is there and the closeover argument is the one that says for instance, I didn't take the external buff. Or I listed the things I'm closing, and in Java, they demand the things that you're getting out of the outer environment be final,
Mhm.
obviously final. It's called obviously final. Right. So
Effectively,
here's some horrible
effectively.
syntax for capture and stuff. Um, and then you don't have to name them. You just use them, and because they're obviously final.
Right. So if I say your comma separated list is your args, then you have a semicolon and a comma separated list of captures. Now, having the empty list of captures.
Right. Yeah, yeah, yeah. There's a shortcut here to say empty. So the goal of the listing the captures is to say
Right.
the declaration that I think about takes only two args or three args or whatever, but the implementation takes these args,
And
these
if I
hidden
want
ones,
to do a no
capture.
capture, then I just type that.
No, you just don't say anything, and then the default you didn't list any captures, you get none. Well, there's another default which says, "Don't tell me about the captures. I'm just going to capture." So yeah,
Right.
here
I would
are.
say the
I mean,
default behavior for capturing is if you don't list captures, you get them all.
So that would be a
But if you
bad
have a
idea.
semicolon and you say, yes, I'm listing out my captures, it's none, then it's none.
here I've
One of
added
the
arg as a capture. Right, I've picked up arg from outside this function outside of scan. He's coming from main. And now you're telling me, Matt, you're trying to tell me that it's a bad idea to not name them. So I'm going to go from, I'm going to go to concrete syntax here. I need to name arg.
take a look at that paper if you're looking for one syntax that is at least that fits in Scala. Maybe that will be closer for you. If you take a look at the section 2.3,
Well,
capture checking of closures, and they make an interesting point of the users. It's too bad that Cameron isn't here. Oh, you are close. Because you see, the other users actually for capabilities, which I think what Cameron is doing in Ecstasy. Like if you have this function test, please don't scroll down.
okay, yeah, I'll scroll up a tiny bit. Oh God, I see. All right, never mind.
Exactly. That was
Yes.
the point. So if you have this function test, you actually don't want every function in your program to touch a file system because file system is actually a capability that can introduce quite a mess. So here they explicitly introduce this capability by capturing fs. You can see this in this curly brace fs right before the return type unit. And
They name it
then
as an argument.
so this is a capture, and now the body of test is a lambda that refers to the capability fs, which means that fs is retained in the lambda. So they actually track what are you capturing at the type system level, and then they can track it and then use it even for capabilities, because now we can restrict that most of your program cannot do I/O, but only certain parts of your program can do I/O, and now you just have to list this in a capture tracking type system level. So in a way, if you want capabilities, you're kind of gonna end up needing something like that, because otherwise you would go back to C and this big ambient capability that everything has access to everything. You don't want to capture file system by implicitly by default. You really want to be explicit about it.
But that would require for Cliff to integrate the capability models inside.
Well, no,
Right
they
now.
just use ordinary type system for extension for that.
Well, I'm not doing any Hindley Moner thing,
So
but
they,
that's
they do
not
they
necessary.
do capture tracking to implement capabilities rather than implementing capabilities per se. That's the way the causality goes here.
Okay. Yeah.
Hmm.
Um, yeah. So this says you don't capture anything out of your current scope. So you're in a function scope, function body. You get all those. Your function body inside of a struct, you get all those because you're a method oop. That struct is inside another scope. You don't get those unless you capture them.
More or less, yeah.
Unless you list them.
explicitly control what the scope of the function, what the function is allowed to call, if you will,
Yeah, well,
and
yeah,
that
he's
is
not looking at the
refined by
entire
the
scopes.
capabilities.
Like in a
Yeah?
classic scheme like thing or Scala like thing, you just keep going up scopes indefinitely, and if you found the name, you took it.
Yeah, so the capabilities kind of control that. It treats them like a resource. So if you don't have the capability to call the file system, then you cannot call the file system. So that's basically driving
Okay, see, I'm not going there. I'm just saying I'm going to the spot of what can I do within simple here without introducing a whole lot more complexities. One of them is simply say you just didn't have any references to it. So going back out here, replace string arg with file system fs, right?
Okay.
And I don't want to say, I don't want to allow you
Yeah.
to call fs.remove
You
and
have to explicitly declare that the skip inherits the scope or inherits the
yeah,
capability
and in
to
order
call
for
the
that to
file.
work, I have to say
Yeah.
you take an
Yeah.
fs.
Yeah. You have to track. Yeah. You have to
Yeah.
track where the f
And
is
if you
used.
don't take an FS, then you get a compiler error. I don't know what FS is. FS nothing.
Yeah. Yeah.
And
Yeah.
it's available in a further outer scope, but I don't care. I'm not going to look that
Yeah.
far.
Yeah.
And I
So
would claim this says I'll look in the function I'm in. When I leave that function, if I'm inside another function, I stop. So I don't look outside of my current function unless it's a struct, and I'll look at that struct and perhaps his nested structs, but never out of another function. I'm looking for a simple set of rules to say what is the scoping rules that I could follow here. Um, and then in this case here, if I'm going to allow it, when I call skip, you're telling me I don't need to pass the skip call an FS because he just found it from the outside. It's not in the explicit argument list. So this call to skip right here does not have to have an FS as an argument
hmm
because I just took the one from main.
yeah, it's basically this. Yeah. It's basically tracking. It doesn't inherit in when because the main is from the outer scope, but you have to explicitly call it and then you can use it. You can use it. And which is maybe kind of different by declaring what do you capture here. It's a little bit different, at least to me. What you can capture inside the function inside the function.
Yeah,
And
I'm
one is treated like the capability to call the file system. The other is treated like what can you capture
right.
inside
If I
out of
can't
your
capture
scope.
a file system, then I can't call it. It's fine. I have
Okay, so
the
if I
problem.
do
I'm
an
not going to solve
import,
all these problems all at once.
so if I do an import outside of main,
Yeah.
it won't be able to find the file system, and I will need to pass the file system into that thing. But if I did an
Explicitly.
import inside of main, that would be able to just call the file system because it would be in its scope stack.
I think that's correct. Yeah.
Well, I heard
Yes.
something I didn't. So the import is where did the file system come from? Main got it as an argument.
Main got it as an argument. So if
Yeah.
I have an import statement above main,
What's an import statement imported? In my case, my head it imports
an import statement is
types,
go
not
get a string from
values.
somewhere and eval it.
Import
Oh, that's
defeats the
different.
purpose. Import defeats the purpose if you have to import the file system contents that you are able to call. So that defeats the purpose of the capture.
So a Java style import does not do an eval. He says, I'm importing a namespace. I don't get a value. That is a difference here. The other thing I heard you said is that I'm thinking import is an eval, but this is, our arbitrary code produced me some file system. I got one. I don't know where it came from. Right. Now that I have a file system, God gave me a file system. What do I do with it? Okay. I can do
Right.
anything I want with what I got handed.
I was thinking of it more in the perspective of if at the top of my file I say import leftpad.
Yeah.
Leftpad doesn't have the file system. But if inside main I say left pad equals import left pad.
Yeah.
That potentially grabbed important secure thing capabilities out of my context just because as a thing that got defined in my context, it has access to all my rights.
You mean like this?
Yeah,
Right. And now I get a left pad thing, and he imported whatever the hell he imported,
including
which
potentially file system is being interacted with.
only if it's inside of left pad. I don't define a file system here. I define a left pad struct.
Right, but
Does
my
left
point is you
pad,
didn't have to hand left pad the file system. If it
yeah,
had an unbound FS object, it will grab it out of my context.
I'm oh, okay. So now in my head, import is it was defined in a different lexical scope. He can't see the FS from main. He has no vision to FS from main.
Okay, so you would say that the
Import's a normal
the
function.
scope that you're in does not pass through that I imported a thing.
No. Import is a function. It took a
It
string argument.
cannot close over something in the context where I did the import.
No, it was defined somewhere else, and that other place has no clue what main and file systems are. It has whatever he has.
Okay,
I,
so
I
if key
called it
needs
as a function.
capabilities, they need to be passed in
Yeah.
as args because there is no closing over that boundary.
I'm sorry, that word. Yes. Yes. No, that's the standard function definition here. I don't know. Import as a eval is fine. But see, here's an eval that here's a version of things that says like this. Okay. What does eval with fs do? Well, he takes that string and looks it up. In what scope does he look it up in? Well, if he looks it up in the current scope, he finds an fs. But I have an fs, so I can just write the code fs.armstar, right? I can just write this code. I got an fs. Fine. So if I eval it, I claim I no more, no less security than I had before.
Yeah, I guess what I want is that eval is sort of born in a no context. And if I want it to
Yep.
be
Yep.
eval in my context, I should be like saying eval,
Right. There's another
comma, dot, or
version.
whatever it is.
There's another version where we talk about what import does or what eval does and how much scope you should give eval. What is Matt throwing in here? Oh my God, a giant thing here, Matt.
An example syntax. On the paper, it's shorter, but one example of what was Aaron asking about is to basically have a module, like module main, and it is to the module that you pass the file system capability. And then
Right.
that can pass it on later to things like logger, where logger requires the file system to do the work, which is then going to accept the file system capability. So you kind of have to have some kind of, if it's not an import, then you have to have like some top level module where you're going to declare and pass the capabilities that you're going to use or allow to be used.
It's like dependency injection, kind of.
Yeah,
I suppose.
I'm not seeing, without going to read the paper, I'm not seeing what this is different from just passing values around and types from the values around. So I need to go stare at the paper and figure out what they're trying to say that's different.
Yeah, and the thing is that you can do this for the entire module, like entire translation unit.
Yeah, but do what? Took a file system, you can pan it off, or you didn't take a file system, and you don't have one, so you can't do anything because you don't have a file system. I don't understand what the difference is. And
Well,
that's what I'm saying. You need to go stare at the paper and say, what are you guys trying to do here?
well, without something like that, usually file system would be some kind of a global object that is just floating around and everyone
Oh,
has
I
access
see.
to. Because you could, yeah, I mean, in Java, you can just instantiate file system class out of nowhere
I'm
in,
sorry.
in any arbitrary method.
I'm coming from the Cameron school of thought on these things, which is you get nothing to start with. And so you don't have a file system. You cannot go get a global file system. There is not a global file system. You ask main to give you a global file system, and main can pass it along.
Yeah, but then the question is, where does it main get it from? And
Well,
so
no, main
then,
gets it because the user starts main. And so at
Well,
that time that
maybe.
it's launched, the shell script says, I'll give you my file system. And you could argue that I need a shell that doesn't.
So the
yeah,
Deno VM has a command line argument as to whether to pass in the file system or not.
Fair enough.
And it either passes a file system into main or it passes a null into main
Yeah,
in the
I'm okay
variable
with
name
that.
file system, which is
Yeah,
like,
right.
that's fine.
I want other things than yes or no, like read only this layer. I'll give you a starting point. You can read from here down and maybe write from here down, but you can't read other
yeah,
things.
they have
More
this
things I want out of resolution.
example later in the paper called attenuation, when they can, for example, restrict a particular directory in the file system should be accessible.
Right.
Yeah, that's also useful.
Yeah, but I think I'm starting from a point of there are no globals. You don't get any globals. You want globals. Main gets the first globals, and that's because whoever starts the program says, "I'll give you what I'm going to give you," which
Yeah.
usually everything. Yeah.
And you could totally imagine a VM that has command line arguments for file system,
Yeah.
true, false, and true.
Yeah, and different kinds of shrinkage of the file system and stuff. Yeah. Here is a temp directory for you, and at the end of your execution, I'm going to nuke it. And furthermore, it's limited to 10 gigs, 100 gigs, whatever. I don't care.
Yeah.
Yep. Yep.
Or FS is in memory. You get something that looks to you like a file system, but nope.
Yeah, I ain't gonna tell you how. It's already in memory. OS is gonna cache anyhow. And then if you make a file and you write to the file and you read from the file and then you delete the file and the OS cached it the entire time, it was only ever in memory anyhow. So I think the memory or not the memory makes no difference on a file system. All right, fine. So I think I think we're running down the end of odds and it's like way more stuff got discussed here than is ever gonna happen anytime soon. So I'm going to go back to finishing out my cyclic type bugs and stare hard at just delaying all things until
So
the
kind
end
of
of the.
simple is
All right.
staying in the forward flow everything, no
Right now,
hanging
it's
out where
staying
I
in the
land.
forward flow everything as an easy way for everyone who thinks about compilers from the the standard C Java world, functional world thinks about them. There is a lot of type inference baked in, but it's all obviously flows from whatever. So the whole promotion logic is just a way to make a one-pass parser that handles forward references.
So I would argue that it's not just for the people who think about compilers. I have taught languages like Python and I've taught languages like C, and students get confused when characters that are below where they are affect the meaning of a symbol where they are.
Okay, well that's big time in Henley Milner. Here, the buff is
Whereas
the
with
bottom.
forward flow, usually if you read the file from the top to the bottom, you
Right,
know what the types are when you
right.
hit a place.
So in this case, as a standard thing that you see in every C in Java, while buff has not yet shown up, I have to go ahead to read. I am limited in how far I have to go ahead to read. It's somewhere in the scan, the struct scan. And I could topologically sort these fields. And then yes, then it would be forward. There exists a topological sort that would let me read the file in forward and have them everything defined.
Yeah, and I would love to have an editor with a nice um,
Yeah.
language built in that they could see the color of that changes when they comment and uncomment the buff that's lower down. And be like,
Ah,
oh, look, when I comment this out and then I mouse over it, its type is undefined forward reference.
right. Oh,
And
I
then
think
I uncomment
IntelliJ
it
does
and
that.
look, now it's not an undefined forward reference. Now it's a buffer.
Right. I thought IntelliJ does that. If I put this code up under Java flavored or C flavored and put it
I
in
mean, we
IntelliJ,
would have to write a language server for
yeah,
simple.
I needed a language server for it. Yeah. No, that's a language server. Well, I mean, you want a language server? Pile in. I'll certainly take a PR with a language server. He's like, oh, I have to actually, make a living too. So things are going to happen in the time and frame allotted. All right.
So that's the plan. If we want much faster progress on AA, we should get you fired.
No, you should pay my bills. I'm fired already. I'm looking for a job.
Again, I
I'm
thought you were on ecstasy at the moment.
no. Cameron ran out of money, and he needs to actually go get funding for his project. And so I set ecstasy aside. I'm sorry. I was actually having a lot of fun. Some frustration because his notion of implementation versus typing are wildly different. Plus, there's syntax issues. But never mind. He had things that he thought were implemented that were not in a major way, and I ended up doing a lot of things I thought I would not going to have to do. Um, in order to drive ecstasy down to like executable code. Fine. But it was really, in the end, it was money issues. So I went and got a job with Derek doing his PE array thing. He was on it earlier, and that was actually a lot of fun. That was porting to basically a weird ass GPU like AI chip. Um,
But I'm not surprised that was a finite amount of work.
right, right. And then so I've pressed that button again. I'm looking. I've got 10 leads running in parallel right now, so something will happen before long.
So back to LinkedIn.
I'm sorry.
I said back to LinkedIn.
Yeah, I hate LinkedIn with a passion. Nonetheless, about half of my leads came out of LinkedIn. Yeah, fine. A lot of people like LinkedIn. A lot of people I know for a long time like LinkedIn. So Cliff says, "Hey, I'm looking." They're like, "Oh, I found Cliff on LinkedIn. I'm looking now." And so I get forward references to what do I get forwarded to people from LinkedIn.
I'm
Fine.
curious to hear your chats of what you think LinkedIn could do better, but that's probably not for this forum.
Oh, it's just I'm not the social person, and LinkedIn has this shit like make a connection, make a connection. Well, if I made a connection to everyone who sent me an invite, I would have 100,000 connections, and the pile of them would be no one I ever knew, and it would be useless for me as a connection because I don't know these 100,000 people. As it is, I have way more than I know anyhow. And my wife's trying to reach me. Let me find out. Hey, no, I'm on Coffee Club still, so. Okay. Bring me a chocolate if you want. All right. Love you. Bye. Fine. That was the standard. I'm leaving Starbucks. Do you want anything from Starbucks while I'm coming home? Um, yeah, there's a lot of shit there. And then the interface is really, I don't know, it's super noisy. And if you're into it in a big way, then it's dense and high information quality. And if you're not into it in a big way, it's nothing. Well, that was weird. Yeah. All right.
Okay, we are on the 2 hour mark.
Yeah. Sorry, I'm getting spam attacks here of various
Mhm.
kinds.
Are they LinkedIn invites?
No, I'm getting the online trading accounts that I have closed some years ago are now getting people trying to log. They're closed and they have no money. Somebody's trying to get into the account, and I'm getting requests to enter a confirmation code for an account that's been closed a couple of years and I haven't tried to log into in a couple of years. So at some point, I need to go call those folks up and say, "Dude, nuke that account." And they probably have a law I can't get rid of the account for 7 years or something, and empty.
There's a lot of finance rules.
Yeah, so there's a bunch of right. So the account lives on, but somebody's trying to log in. No, 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 don't do it. All right. Yeah, we're well into the mark here. If you got something you want to add, we can do that. Otherwise, I'm gonna go figure out how to tell Tasty Trade to them.
All
Don't.
right, undefined forward reference until next time.
Yeah, maybe that's the right answer. So I'll stare at doing something here. Get rid of buff and promotion. Do go for my promotion logic here. And the
So
rules
what?
on stopping at struct make some sense.
Yeah, yeah. So what would be the link or promoting? So they're solving the same thing.
Yeah, it's the promotion is
The promotion has with some rules has better potential because if you're delaying, I think that you
here
ignore it.
here I'm going to promote is
Yeah.
odd out of a function
Okay.
and say in any enclosing scope, somebody can have a finally defined variable with a function.
Mm. But on the flip side, if we are setting us up to track a really big promoted variables that need to be bound, promoted symbols that need to be resolved at the end of, because that's only one buff. But if you have a hundred or 50 or something, wouldn't that you have to
Well, if you got 50 variables named buff and 50 nested
no
scopes, I claim you have an
if
issue.
50 promoted unbound symbols that they're promoted to the
Oh,
outer code. So
you'll get
let's
that.
so
No.
you
Yeah, if
mm,
I write a big nested script function inside of some other big nested struct
So
object. I'm expecting lots of these.
at each block you have to you will have a list of unpromoted variables that go to the next
Right, and
to
here
the
this
next
is
call.
where I'm like, what are the rules here? Here I want to say fs if fs is a finally defined function in some outer scope, I'm kind of okay taking it because it's a free constant.
Mhm.
It requires no implementation strategies or anything. I don't have to pass it as an actual variable. There's nothing to implement here. And the discussion that says it has to appear here to stop me from finding it here is a thing that I'm thinking about. Whereas if it's a struct, not a function, if it's a struct and I say, I found one here, don't take it anyhow that I found it, then that one makes more sense because it means skip has to take an extra argument. It's not a constant. So that's like Java's final fields in their lambdas. There's an implementation difficulty. I'm basically heading into a closure. I don't want to deal with a closure. That's separate from saying, actually, Matt's still on here. Then from saying, because it's a struct, I don't take it, or it's not a final constant, I don't take it. That's kind of a funny thing. What is if a final constant struct? It's a completely well known ahead of time all constant bit struct. Well, I could take that. Besides being all constant bits, it means you know what the hell it is you're looking at anyhow because it's all constant bits. File systems are not all constant bits, so they don't fall into that camp. So my real rule is to say, if I head out of some struct here, like struct, I'm going to take this argument, a hidden this argument. That's the argument I'm taking that covers all the things that are inside of a struct. But if I go outside of struct, I'm only going to take final constants. But I could take final constants at any level, and then I'll just put the constant there. There's no implementation issue. Now, does that cover capabilities? Well, if I start by saying there's no globals, and so you don't have any free I don't think I need capabilities. And the separate one, it says, do I want to say you have to name fs to pass in this versus taking it from above? I'm there, and I don't need a special capability or not. I'm just going to say you got to pass the argument. You have to have this. You have to have an fs. Okay, you do. That's what you get out of like Java without any trouble. So
There was some details about the capabilities. I do not remember right now. There's like passing arguments from function to function, but there is something else that enhances that capability thing.
right. I understand that I don't understand. I know that in the case of the file system, I have an easy answer, which is you don't get a file system for free. You got to go ask for one. In my case, you get an import of sys.io.
Yeah,
Right
and
now.
in the case of Scala,
This
there was
trying to that you get a file system this way. And we can argue that I'm going to say, no, you're going to get passed on main, and the main's going to have a file system. Sys.io gets passed into main. I'm not calling it file system, I call it sys.io, but file system, right?
Yeah, and the trick in Scala was that you can leave that fs capability. You wouldn't pass it to skip. It will be inherited like an implicit argument. That was the extension of that idea, the Caprese project.
Well, I'm inheriting it. I am inheriting it here. If I don't say this, if I don't have this fs here, you get a free inheritance of a file system that you can call rm star on. And the discussion was, that's kind of dicey. But of course, you're writing a function inside, you're writing a struct which has a function inside of main who does have a file system capability just by default. So yeah, you can write that code.
Right. My instinct there is define your structs outside of main.
And
And only pass in the file system if you want to pass in the file system.
That's right. Exactly. That's my thinking. Don't write this struct inside of main.
So the difference here that if you don't have fs in the main, that would require that you inherited that capability from somewhere. It doesn't require you to stack the functions in order to import the fs scope inside to be reachable from skip. So the function skip would declare that it needs that capability from somewhere to capture that syntax.
Well,
so here you're lucky that fs is just above in the outer scope. But if it's a freestanding function, that fs would have to come from somewhere, and
I would
that's is
claim
the yeah.
that's done by the existing syntax of just having an argument called fs.
But if you when you call skip, you wouldn't you are obliged to pass the fs. But in the Scala case, it is passed like an implicit argument
I know.
in the scope. Yeah.
I've
It's
watched,
something
I've
like
looked
that.
at Scala implicits, and they
Yeah.
it's like
It's something like that. So it's
yeah,
not the
right.
entire story.
No. Right. All right. We should stop now. I don't know about implicits enough, although I've watched and tried to read Scala's code with implicits, and it's just
Eh,
horrific. I don't want
it's
to do it.
fun. No, it's easy.
Okay, good. I'm happy for you. I'm not writing Scala.
Uh, yeah.
And we're gonna let this go another day. And even right now, I do have a global IO in simple because I'm trying to make life easier for people. But I could instead say it only shows up on main, and that'd be okay. And then you have to pass it along.
It is in the same sense like a global, but it's kind of restricting from where that global comes.
Yeah, I kind of get the feeling. I have to sit down with the paper and stare at it, and it's time for me to be done. We're at 2 hours and 15 minutes here.
Mm.
No. All right, and here's Zoom hiding their own controls from themselves, so I can't stop the share. All right, it was good, and that we went round and round a long time on that one. Sounds great, and hope to talk about this stuff again next week. Maybe I'll have something implemented. It won't be everything that we talked about today, though. All right, bye-bye.
Uh,